Welcome to Unit 2, where we start by talking about rational expressions here. So find an equivalent rational expression. And the big idea, whenever we're talking about things that are rational, we're talking about things that are written as fractions, written as the quotient of two quantities. In this case, rational expressions are the ratio, the quotient of two polynomials. So we have a polynomial in the numerator and a polynomial in the denominator. So find an equivalent rational expression in lowest terms and identify the value or values of the variable that must be excluded to prevent division by zero. So I want to know, when is it undefined? So we've got two things here. Simplify it and then say, when is it undefined? So let's tackle this first rational expression. Our game plan is to factor these expressions. So if I look at the numerator, that's the difference of perfect squares. So I've got an x plus 6 and an x minus 6. In the denominator, I have a trinomial. Luckily, the leading coefficient's 1, so I just need to ask myself two questions. I need to say, self, what multiplies to negative 12 that adds to negative 4? What multiplies to negative 12 that adds to negative 4? Well, that's x minus 6 and x plus 2. So, now that we're at this point, we can simplify this expression because this x minus 6 factor in the numerator and that x minus 6 factor in the denominator, those divide to 1. So I'm left with x plus 6 over x plus 2. That's the first part of these problems. And then I want to know, identify the value or values of the variable that must be excluded to prevent division by 0. That's when I'm undefined. So when is this expression, this original expression, undefined? Well, let's look at this denominator here in factored form. If we use the zero product property, we get that x cannot equal 6, x cannot equal negative 2. Because if you plug those numbers in, if you plug in 6 to the denominator, you'll end up dividing by 0. If you plug in negative 2 to the denominator of that original expression, you end up dividing by 0. So those are the values that we exclude. The second one here, 3n squared minus 5n minus 2 over 2n minus 4. So to factor that numerator, it looks like we're going to have to use the AC method. So what multiplies to negative 6, 3 times negative 2, that adds to negative 5? Let's see here. Negative 6 and positive 1 work. Negative 6 add to negative 5. So we're going to split the middle term as 3n squared, and I'm going to split that negative 5x as minus 6n plus 1n minus 2, because that middle term adds to negative 5. Now that I have four terms, I group. I take out a GCF of 3n, and I'm left with n minus 2. Well, I need an n minus 2 in this set of parentheses. I really don't need to take anything out, so we take out a positive 1. My new GCF is n minus 2 times 3n plus 1. So those are my two factors of the numerator. I'm not done. I shouldn't box that in. So the numerator is equivalent to n minus 2 o times 3n plus 1 divided by, well, if I take out a GCF in the denominator, I'm left with 2 times n minus 2. Well, that common factor there divides to 1, and we're left with the expression 3n plus 1 over 2. Now, when is this expression undefined? How do I prevent division by 0? When is the denominator 0? The denominator is 0 only when n equals 2. Look at that denominator there. 2 is never going to give me 0. That only gives me 0 when n equals 2. So we say n cannot equal 2. And the last one here, we've got y to the third minus 8 over y squared minus 4. So hopefully you recognize that numerator is the difference of perfect cubes. So I need my linear term and my quadratic factor, my linear factor and my quadratic factor. I get y minus 2, square the first, multiply them, square the last, square the first, multiply them, square the last, same, opposite, always positive. That's how we factor the numerator, and the denominator is the difference of perfect squares. So we get y minus 2 times y plus 2. The y minus 2's divide to 0, so we're left with y squared plus 2y plus 4 divided by y plus 2. That's my equivalent expression. Now, when is this expression undefined? When is the denominator equal to 0? Well, let's look at the factors of y minus 2 and y plus 2. So we have to throw out, if we use the zero product property, we have to throw out positive 2, and we have to throw out negative 2. So we might say y cannot equal plus or minus 2. to just simplify that up. So this is my equivalent expression. They look different, but they're actually the same, but we have to throw out plus or minus 2. We can't plug those in. That's when these expressions are undefined. So really, rational expressions, when we simplify them, all we're doing is we're factoring. All we're doing is we're using our factoring techniques. Number 2, state the least common denominator of these two rational expressions. So the least common denominator is, well, this has a denominator of x plus 7. This has a denominator of x. So I want them to be the same. But the thing is, there's no way I can just make this x into a x plus 7. So what we're going to have to do is we're going to say our least common denominator is x times x plus 7. You need a factor of x, and you need a factor of x plus 7. So that first expression has the x plus 7, but it's missing a factor of x. So if I stick an x in the denominator, I'm also going to have to multiply the numerator by x, so because all I'm doing here is multiplying by 1, which doesn't change the value of an expression. So when I distribute here, I get 3x squared plus 25x over, I'll just leave that in factored form, x times x plus 7. The second expression has the x, but it's missing the x plus 7. So let's multiply that by x plus 7 over x plus 7. If I distribute, I get 3x plus 21 over, I'll leave that in factored form in the bottom. Those are my two equivalent expressions. I changed the way they look, but they're still really the same as where we started. All I did there was I made sure that they had a common denominator by multiplying the numerator and the denominator by the same value. Determine whether or not the rational expressions here are equivalent. Explain how you know. So here's my first rational expression, x plus 4 over x plus 2 times x minus 3. And then the second expression, I should definitely factor that numerator. That numerator factors as what multiplies to 4, that adds to 5. Make sure you ask yourself those two questions. And you get x plus 4 and x plus 1. 4 times 1 is 4, 4 plus 1 is 5. Over x plus 1 over x plus 2. Okay, but wait a minute here. I have a common factor of x plus 1, so those divide out to 1, and I'm left with x plus 4 over x plus 2 times x minus 3. So are they equivalent? Yes. These two expressions are equivalent. Why? Because it says explain how you know. After we divided out the common factors, the expressions were the same. So they are equivalent because all I did, remember, equivalent means they look different, but they're actually the same. So this expression is really the same as that second expression there, because after you divide out that common factor of x plus 1 from the numerator and denominator, you end up with the same thing. So they are equivalent because after we divided out the common factors, the expressions were the same.